Okay, so first part, I got x over 1 minus x cubed, so that's going to become x times by 1 minus x to the minus 3, and then I'm going to have to use the binomial expansion, so I'll just put that in. So this equals x times by, and then it's the x here is minus x and n is minus 3, so its first term is 1 plus nx, so it's going to be plus minus 3 times by the minus x, and then plus n, so that's minus 3 times by, that'll be minus 4, all over 1 times 2 is 2, and that's x squared, and x in this case is minus x squared, and that equals x times 1, that's plus 3x, and that's going to be positive there, that's going to be positive there. 12 divided by 2 is 6, so it's plus 6x squared, and that equals x plus 3x squared plus 6x cubed for the first part. Second part, use this result, okay, with a suitable value of x to obtain a decimal estimate for the value of 100 over 729. Well, first thing I'll notice is the cube root of 729 is 9. So that hints at x equals 0.1, because that means the bottom bit will be 0.9. So let's just try that. So we got, if x is 0.1, we get 0.1 over 1 minus 0.1 cubed, which equals 0.1 over 0.9 cubed, which equals 0.1 over 0.729, which does equal 100 over 729. Okay, so it's straight like that, but sometimes you have to double it or divide by 2 or whatever it may be. So in this case we got 100 over 729. Straight away just substitute in 0.1 for x will be 0.1 plus 3 lots of 0.1 squared plus 6 lots of 0.1 cubed, and that is going to be 0.1, that'll be 0.03, that will be 0.006, so that is 0.136. Okay, so here we now we've got to show that this bit is the same as that, and hence find the first 3 terms of the binomial expansion. Right, let's start it off here, but no, I'll start it up here. So part 3, we've got x over 1 minus x cubed equals x times by 1 minus x to the minus 3. But I wanted to have a 1 over x, and I haven't got 1 over x, so I'm going to take out an x there, which will help us. I'll put the square brackets in there, so I can just concentrate on this bit here. So take out an x, and that gives us 1 over x, because x times 1 over x is 1, minus 1, and that's to the minus 3. That's looking pretty good, but it's the other way around, so I'm going to take out a negative, so that equals x, square brackets minus x, to 1 minus 1 over x, to the minus 3. That's looking pretty good now. Now I put the minus 3 back into both of these using sort of laws of surds. So that's x times by minus x to the minus 3 times by 1 minus 1 over x to the minus 3. That's looking pretty good. And then this bit here is x, and this will be over, it's going to be minus at the front, isn't it? Because we've got 3 of them, minus x cubed. Well, I suppose minus x cubed, let's see where I get it from. And 1 minus 1 over x to the minus 3. And that is minus, 2 of them cancel out, so 1 of them cancels out to leave you with 1 over x squared. And then 1 minus 1 over x to the minus 3. So that's shown the first part. Then use binomial expansion, that bit there. So that's going to give us equal to minus 1 over x squared. And then we've got to do this bit, so it's going to be 1. and then minus 3 times by negative 1 over x, and then plus negative 3 times negative 4 over 2 times by negative 1 over x squared, which equals minus 1 over x squared times by 1 plus 3 over x plus 6 over x squared, and that equals minus 1 over x squared minus 3 over x cubed minus 6 over x to the power of 4. So it's done that bit. And the last part I'll do in red, part 4. Comment on the suitability. Well, it's not suitable. For various reasons, but each one here, but this is it's diverging. The numbers are getting bigger and bigger, diverging as x, well, what have we got? 1 over x is not less than 1, because we've got same part in value 2, so we put in x as 0.1, so 1 over 0.1, that equals 10. And so when we've got here, it's going to get bigger and bigger and bigger. Also, if x equals 0.1, first 3 terms are negative, but 100 over 729 is not negative. So another reason it's not suitable. It's going to get way, way, way bigger. And the next one's going to get even bigger. So that's question 10 and the whole paper done.